Okay, this is a video about constructions with a compass and straight edge. So the only tools we use are a pencil, a straight edge. Here I'm using a ruler, but I'm not going to use it to measure, and a pencil. So the first construction I'm going to do is a perpendicular bisector. So let me write that down. So it's a perpendicular bisector. And I'm going to sketch what we're going to do first before we do anything else with it. So the first thing we do is we're going to draw a segment with our straight edge, a line segment. And then what I'm going to do is cut that segment in two. Sect means to cut, bi means to cut in two, bisector means to cut in two, like bicycle means two wheels. And perpendicular means I'm going to cut it at right angles. So, my goal is to do this, have a line that bisects this segment. How I'm going to do that is I'm going to take my compass and I'm going to draw a big arc over, it's going to be over half the length of the segment. I'm going to draw a big arc here, and then take my compass point, put it here, draw a big arc here, and then in between those I'll have it. So it'll make more sense once I do it here. So let me go up here, and I'm going to now draw my segment. There's my segment. Now I'm going to open up my compass so that it's over halfway. You don't have to be exact in this, just make sure it's over halfway. So that's obviously over halfway, over half that segment. And I'm going to draw a big arc. An arc is part of a line. And so I put my compass point on the end point of the segment there and drew a big arc. Keeping the exact same setting, and that's important, I'm going to put my compass point here and draw a great big arc. And so I have that, and then I'm going to take my straight edge, and from where these two arcs intersect, they intersect at a point. Where these two intersect at a point, I'm going to draw a line. I'll put arrows on the end to show that it's a line. And so this line has cut this segment exactly in half, so that this is the midpoint. And it does it at right angles. So that's a perpendicular bisector. The next one we're going to do is we will do an angle bisector. So I'm going to take an angle. Let me erase that. I'm going to take an angle. I would do medium-sized acute angle would make it easiest. So I'm going to take an angle. So an angle is composed of two rays with a common endpoint. So I'm going to go ahead and do that. Since they're rays, I'm going to put arrows on this end. And then let me get my compass, which I had put up here. And what we're going to do, we can use the same compass setting on all these. We're going to do 3 different arcs. On the second and third arc, it has to be on the same setting. On the first one, it doesn't really matter. So I'm going to draw an arc somewhere out here. So I drew an arc there. Okay? Exactly where it is, it doesn't matter. But now I'm going to use the same setting. I don't have to here, but in the next 2 steps, whatever I choose, it has to be the same setting. So I'm going to put the point of my compass where that arc intersects this ray down here. And I'm going to put another arc out here. Now, I'm going to take my compass and I'm going to take the point of it, and where this arc intersects this ray up here, I'm going to put the point right there, and then I'm going to draw another arc out here. Okay? Now, from the vertex of this angle to where the 2 arcs intersect, right there at that point, I'm going to put a ray. And so let me line that up carefully. I'm going to put a ray out here. Could line that up a little more carefully. But so now this angle here and this angle here are equal. Okay? And this is, I didn't put the name, but this is an angle bisector. Now, the next thing we're going to do is two congruent angles. So I'll write congruent. Remember, congruent means that the measures of the two things are equal. Congruent angles. So I'm going to draw two congruent angles. And so I'm going to draw one angle here, medium-sized acute angle would be, makes it easy. And so I go up here, I go up here, okay, and my goal is to make another angle just like that. Where I put it, it doesn't really matter. I'm going to put mine over here, I think. So I'm going to have a bottom ray like right here, okay? So remember, an angle is two rays. So here's one of my rays for my new congruent angle. And down there is fine. It looks like it's roughly parallel with that, but it doesn't have to be. It can be anywhere on there. And so now what I'm going to do is I'm going to take the point of my compass here and a medium-sized arc here. Again, it doesn't matter exactly where. I'm going to draw an arc that crosses both of my rays. Okay? Taking that exact same setting, I'm going to go to this other ray down here, and I'm going to put the point of the compass right at the end point of the ray and draw a big arc that intersects that ray also, but also goes way out here too, okay? Now I'm going to use my compass as a measuring device. So I'm going to take the point of my compass here, and I'm going to take the pencil part of it, and my hands are getting in the way here, but I'm going to move this in a little bit here so that this is basically measuring this, the width of this distance between here and here. I'm going to put a little arc, I'm a little too far up there, a little arc like right there to show where that is, okay? With that same compass setting, I'm going down to this other ray, and where this arc intersect, I'm going to put the point of my compass there and draw a little arc, okay? And then now, as you can see, this goes out the same distance as this. This tells us how far this is open. So I'm going to take this here and say how far it's open. So I did that with measuring with my compass. So these angles should be the same now. And so what I'm going to do is take and draw a line or ray from the end point here through where the two arcs intersect. And that gives me a congruent angle. So this angle is equal to, the measure of this angle is equal to the measure of this angle. The next thing we're going to do is do parallel lines, or they could be parallel rays. So we're going to take these and put them there. And then this is actually the same thing as congruent angles. So it's parallel lines. And so I'm going to take this and I'm going to draw an angle, but the bottom ray I'm going to show really long. I mean, obviously a ray is infinite, but I'm going to draw a really long part of the ray there. And then I'm going to put an angle up here. Oops, I slipped a little bit there. So I'm going to put another ray here to make an angle. And what I'm going to do is, if you think about it, and actually if I want this to be a line, I can make it a line here too. So let's make it, since we said parallel lines, let's make it go down here like this, okay? And we can put an arrow on both ends, so that makes it a line. Well, if I go out here to some arbitrary point out here, and if I draw another angle here, that's exactly the same as this angle, I think you can see that these two lines are going to be parallel. Okay, so we're going to do that now. And in high school geometry, you could prove that also, that essentially these two angles are equal. They should be, I think, corresponding angles and so forth. So I have these two. So what I'm going to do is draw a congruent angle right here. So I'm going to go back to all the steps I just did for congruent angles. I'm going to draw an arc. I'm going to go over here to this arbitrary point I picked, and I'm going to draw an arc. I'm going to measure from here to here, and also from here to here. And so I'm going to take this measurement, I'm going to transfer it over here, and now I'm going to draw a line between this point and this point. And these two lines, this line should be parallel to this line. Okay, those are the major constructions. Another sort of fun thing we did was we drew a hexagon, a regular hexagon. A regular hexagon is sort of fun to draw because you can take a circle and you can draw it around like so, a full circle. Make sure you get the point in there so you can see the center point. Sorry, I moved that a little bit. So the center point is right here. But I'm going to keep the same setting that I drew that with. And from the center out, well, that distance is a radius, okay? And so I take this, and for a hexagon, if I take this and start at some point out there and draw it, and each time an arc intersects the circle, with the distance here of the compass being the radius, it is going to produce something very cool. And you can see what I'm doing here. I'm going around. This one should be where I started if I did it right. And this one should be roughly there. It's a little bit off, but it's close enough for this. Those aren't necessarily showing up really good, but I have an arc here, arc here, arc here, arc here, arc here. And now I'm going to connect these arcs. So arc and arc there. And connect not the arcs, but where the arcs intersect with the circle. So I'm going to connect those points, each of those points. So I'm connecting those. And I'm connecting here's another one. Here we have two more to go. So there and there, and then there and there. And what I have done is I've created a regular hexagon, 1, 2, 3, 4, 5, 6 sides with this center. The other neat thing about hexagons, if I go ahead and take these points through the center and connect them, I will actually create a series of equilateral triangles. And I think you'll notice that each of those equilateral triangles, the length of the side, is the radius of the circle. We can say that the circle is circumscribed about the hexagon, or the hexagon is inscribed in the circle. So that's pretty neat. With that, I'll go ahead and end this video. And